Okay, so you know, this is going to be kind of open-ended, and I have some things that I would like to figure out and understand, and some comparable methods. But um, there's some data that I want you to work with, but there's a lot of open possibilities about how you approach the project. So the basic goal is to kind of look at, hey Eric, um, to evaluate evacuation times and survivals of people lining up. No, they're not lining up, they're living. L-I-V. Sorry, they're living in the tsunami hazard zone. And we're going to work with what's called the XXL, the extra, extra large tsunami. When I started teaching this, the XXL did not exist. And this was prior to the quake in Indonesia. So 2005, I think, is when they had that sub-ocean landslide that generated that tsunami. And so at that point, the tsunami line was quite a bit lower. The expected tsunami line was lower. So a lot of the evacuation plans and the data was based on that lower tsunami plan. And then after the 2005 tsunami, they looked again at some of the modeling, and then they've done other kind of modeling statistics, and they've come up with this XXL line. So we're using only the XXL line for that. So it's kind of the worst case scenario. So if people can get to that, then if it's a lesser tsunami, they're still okay, right? So we're just going to work with that one. And so there are lots of things you can do with this. You can, in addition to just looking at some kind of network analysis or raster analysis based on, from the tsunami line, what's 20 minutes? Because that's about what they think people have, right? 20 to 30 minutes if it's a coastal tsunami. If it's a Juan de Fuca tsunami. But if we have a local earthquake, the tsunami is not going to be the only problem. There is landslides that will be generated, and that you guys heard about that in Nepal this week, right? So a lot of people were killed. They had no tsunami, but they had landslides just shaking things loose. If it's winter, landslides are predicted to be even larger because soil is heavy and wet, and so and also has that lubricant of water, so that can cause larger landslides. So you've got a time element here that can change things. There's also liquefaction, which is when the ground turns to soup, almost like quicksand. And so that happens from unconsolidated sediment like sand and gravel fill. And then when you get ground shaking, water gets pushed up between those sediment pieces and just pushes them apart. And that's what happened in the Loma Prieta down in California when the causeway sunk, because all of that causeway is built on fill. And so when they had the ground shake, have you ever been to the coast and you put your feet, and you just kind of stomp up and down and it just turns to muck? That's kind of what happens on a huge scale. So there's liquefaction that could happen. And then there's other thing, they just look at ground amplitude, how much the ground can actually move up and down. And that would, break roads, that would break, lines, water lines or gas lines. So there's a lot of things to look at. So a couple summers ago, was it last summer? Oh my God, it was last summer. Some students and I got to go with the Oregon Emergency Management team, and we worked in each county with their emergency managers, and we circled on a map areas that were supposedly outside the tsunami inundation line, but had concentrations of population where they thought people would congregate in the event. And the idea is that people could be isolated for 2 to 4 weeks. And so by trying to identify places early, maybe they could start doing prep, or maybe people could, drop food in if they know what they are. So I have a lot of data for you to work with. So there's kind of two approaches here. One is you could develop a network analysis service area, right, based on the service area stuff that we did. So basically, with the road layer, a coastal road layer, and the tsunami layer, you could determine from every vertice along where the road and the tsunami cross each other, How far is a 20-minute walk at 1.1 meters per second, right? And so you could then, once you get that polygon, then you can kind of figure out how many houses are not within that, how many hotels are not within that. So you could use that method. There's another method that I got from a man named Nathan Wood at the USGS, and he has developed a tool that you can add into ArcGIS called the Pedestrian Evacuation Analyst Extension. And I have that tool for you, and I have their documentation workbook for you. And I've only started to look at that. I did the reading. They did a case study in New Zealand, and they talk about how they applied this to New Zealand. So you can choose either method you want to work with, and we'll just see how it goes. For the network analysis model, you need a DEM, you need roads, you need population, county boundaries. I have all of that for you. For the USGS study, you need a DEM and land cover. I have that. Hazard layer, I have that. Survival islands, I added that in. Path distance, I don't know what that is. I'm wondering, I haven't read this enough, but I'm wondering if that might be roads. That's a raster that's turned into roads for distance from a place, so we'll have to look at the documentation for that. They had something called vertical evacuation, and this is something that they're doing in Japan, and they're talking to people about along the coast. So what they found out in Indonesia was a lot of people couldn't outrun the tsunami, and so they went up into hotels, and many of those people survived. So enough of the hotel was stable that if you could just get up, you could be safe. And so one of the things they modeled into their New Zealand model was, were there tall buildings? Were there parking structure? Were there small hills in the middle of town that people could get up to? And so that was another thing. Population, I'm getting that for you. I have some of it, but not all of it, but I'll have it for you by tomorrow, I think, and county boundaries. So I think I have most of the data that you would need to run all of these things. Except what I don't have is, I don't know where the hotels are in that area. I don't know what the summer population is, because you have a tsunami in May or in April, you're going to have to deal with less people than if you have one in July. And so I don't know what the area summer populations would look like. So there's some data you could kind of make some phone calls. Most people are pretty, in the past, have been pretty open about sharing stuff with students. So I have some things to consider. Population ages. Nathan Wood in his model models different ages of people. How fast would a child be able to move out? How fast would an elderly person move? They model in, if you wait 10 minutes to get going, can you make it out, that kind of stuff. But I think it's still important to look at what is the makeup of some of these areas. Where are the concentrations of preschools? I also have school data, hospital location data, that kind of stuff. The other thing to think about is minority populations. So I've given you the evacuations, is that right? COULD, isn't that spelled right? Mm-hmm. Huh. That people can enter okay, that's better. All right, so I've got Hispanic, along the coast, the largest minority group are Hispanics. Most of them are working in service industries or fishing industry. And many Hispanics, speak English and read English just fine. But there are many Hispanics and associated undocumented Hispanic workers who do not speak English. And so most of the evacuation signs, most of the evacuation maps are all in English. And would it be wise for some communities to think about bilingual maps, or maps that you don't need language for at all? The other thing that makes me crazy as a loon is the you know, the evacuation sign, the tsunami sign with the big wave coming up and the little man running, many of these are pointed toward the ocean. So if you didn't know the area and you see the little wave coming from your right, if I'm scared and it's rainy, I'm running left. Well, that actually is where the ocean is. They don't have they don't have signs that point away from, which I think is just insane as well. In Walport, homeowners take down the tsunami evacuation signs because they move property values down on that spit. So there's a lot of interest in this kind of stuff. So I've got just all kinds of things you could think about adding to your project. Viewshed analysis. You know, if you did put a beacon at some of these assembly points, how tall would it have to be for enough people to be able to see it on a rainy, foggy coastal night to get there? So also I've got some landslide information, liquefaction information. There's a lot of information. You can just, Jacob's just rubbing his head. He's going, oh my God, it's so much data. So what I want is a geodatabase, a feature data set, and I don't want all of your processing data. So you might want to scratch, and if it works, then throw it into your good geodata set, right? So because this could just be huge, right? So you're going to be working with a lot of stuff. I'd like a one-page, just kind of summary report. What did you find? Kind of state what was your goal, so what were the topics you were addressing. A little workflow, half-page, page, just what you did and kind of what was the process, and then a list of the data that you used, and kind of what did you input and what did you get out at the end. I don't need to know that you had, 8 rasters in between kind of stuff. And then a poster showing your results. So, and what I would like to do, if it's okay with you, is just throw away the final exam and add these points. So you guys don't have to, because if you can do this, I don't need to give you a final exam. So that's kind of what I'm thinking. And also I hate grading those things. Okay, so I've got a bunch of resources here, as well as, so let's look at the, yes, we're going to save that because hopefully it's in here. So there's some quake resources. So here are the list of evacuation maps along the coast, Brookings, Florence, Gearhart. You can see where they're going to take people. Is it reasonable? Using that evacuation, that's another thing. You could just evaluate their evacuation. How many people could they get out with that route? Is the route, viable? Here is the evacuation installer. So it's a zipped little program that you add into ArcGIS. And this is their little handout, their worksheet on how to use that tool. So if nothing else, even if you don't want to do this, I think it would be fun for you just to take a look at what they did and how they worked through it. It's basically a tutorial that's meant to help community planners take this tool and put in their own data and use it. And it tells you how to install it, talks about the purpose. They have a workflow here that kind of shows you what they went through to develop that. I just think it would be a nice thing for you to look at. So they have tool names and input files, and like I said, I've just started looking at this, so we can work through it together. I don't know that I'm going to be much help because I don't know what to expect from this, but they talk about here's all the pieces of the tool once you add it. So there is that. Let's see, what else? I have got a report that they submitted to US and had published last year that talks about travel speeds. So it's and is this the other one about New Zealand? No, that's the community. So I just had some of the data that he sent me that he thought would be useful. And then let's see, what else have I got for you? This is the land use data for the entire state. So I have that. if you need that for the model. And here it's zipped. I should just take it out of here so it would be somewhat smaller, so you don't have both the zipped and the unzipped. Let's see. And then I have all of the data that I've created and put together for the project that we're doing with Dogon, or with Oregon Energy Management. So let's just take a look at what's in here. I'm going to remove that and catalog. Here we go. La la la. So if you open up the feature data set, there's a hazards feature data set, and it has coastal liquefaction. It has landslides from '95, so they're a little old. You might be able to find more current landslide data if you want. Assembly areas, oh, these are already here. So these are places that people are supposed to, wow, do I just have one assembly area? Come on, seriously? I've had such weird GIS data. Did I screw up the assembly? This looks like 1 point, doesn't it? It is 1 point. Well, that's not good. I'll have to, wow, I'll have to give you the assembly data. Let me look again. This stuff, you know, I've just had strange corruption stuff yesterday. Okay, so the assembly data is corrupted. I'll send that to you as a shapefile. Let's see. Let's hope everything else works. Coastal liquefaction. There it is. Okay. And this is showing you, yeah, susceptibility as I think it's 1 to 3 to 0. And I do believe that the data properties, I'm hoping they stayed with this. They're the descriptions. Let me take a look here. Well, that's worrisome that those assembly points are bad. Huh. I think I have a little ghost on. Yeah, so some of this has the metadata with it. So this should tell you when you open details, data details, it will give you the where that came from, the credits, and just some basic information about what that's about. Let's see. This tsunami polygons, I made several versions of these because I wanted to be able, so here's just the run-up line, right? Zoom to layer, there it is. So there's the tsunami run-up line just as a polyline, but I also wanted it to be a polygon for a couple reasons. That I used it to clip some other stuff with, and I made it an extended polygon, so when I did mapping I could show that tsunami as a body of water over the landscape. So you've got some options in there, and that all has metadata with it. The islands, here are the population islands that were generated, and there's a bunch of them that one of my tasks this summer is to go in and clean up some of these like little fragments, like those. So there's an island. If we put on the base map, you'll be able to see, you know, or if I put on the tsunami polygon. So the tsunami comes up around that, and that would be kind of an isolated population within the tsunami potential run-up. What else have I got? So I've got infrastructure. So I've got really nice county outlines: fire stations, hospital, law enforcement, nursing homes, public buildings, schools, and the UGB. And then for population, right now I've got census blocks 210, and they have the Hispanic data, but they don't have all the age data. So I'm going to work on that too, to go download the age data and get that in that for you. But when you look at all of this, it does tell you housing units, which is kind of interesting, because I think the standard, what they were trying to do is decide that for every housing unit there 6 housing units. I'm going to just estimate based on, I mean, because really this is just an estimate of where those are anyway. So, I mean, there's some things that you can do that would maybe account for half a block being left. So I just threw a whole bunch of stuff at you. So you can go through that list and think, what concrete things can you do? What things are maybe kind of bigger, more researchy, or kind of just processing and playing with, and what do you want to come out? And I will put up, so here's an example of what they did for Astoria, and it was okay. I'll get out some of the other tsunami work so you can kind of see the kind of things people were doing.
For the last year.
Yeah, last, I have a whole bunch of older ones, I think. So they pretty much, and what was really sad about this is they never really quantified this, which would have been great. They could have, from the tsunami run-up, clipped how many buildings. I mean, it would have been really helpful for somebody to see, okay, there were, 72 schools, 25, I don't know, whatever. It would help someone other than just the visual is nice, but a number would have been useful. This is their evaluation, 15 minutes or less was the walking speed. But they don't really tell you what they found, right? I mean, it's up here, but you would have to look at each one of these roads to try to figure out. Yeah, I would have maybe highlighted the roads that were in danger, the sections of roads, something like that. What is this one? I can't even. Areas and population. So they did a view shed. So how much population would be outside that view shed? How much could maybe see a beacon? And then this was looking at population by ages. So I'll put up some other stuff just to give you ideas. But you've got, I think, most of the data you need to get started. I've got the DEM for the coast that I'm going to zip up. And it's about a gigabyte once I zip it, I think. So, for those of you who want to try this modeling, the DEM is 10 meter. The land cover is, I think, 30 meter. So I would try to reclassify that 30 meter as 10 meter, because I think you want as small as you can for this. And 10 meter is still pretty big when you're talking. How big is a road? Yeah. Yeah, so I'm really curious, it'd be interesting to see how accurate. It'd be fun to go out and just try to walk some of these areas once the model runs to see how you really could get out the time that they say. Yeah. Road trip. I know. Yeah, but not to the coast, okay? That's right. So is that final thing okay with you guys? I mean, okay. If somebody wants to quietly email me and say, please have the final, I'll do it because it's in the syllabus. You don't have to do it publicly.
Then you can take that if the person wants to.
That's true. Okay. Oh, video. Okay, so I just anticipate a lot of questions. I would grab data and just kind of think of a work plan, make some really solid things you can address. You're going to need your roads however you do it, so you might want to pick a community and then pick the county roads that match that rather than do that twice. So anyway, I'm going to go ahead and close that. Oh, I have to get you the assembly points and, okay, hold on. You know what, can you wait? Let me just clean that up now. If you won't take that, let me just add the assembly points right now, and then you can take what I'll zip up that other DEM. And then Travis, I'm going to put all this on a flash drive and bring it to you, because you can't download it. Okay.